All right, so we've talked about the combinations of three parts of a triangle and which combinations can be used to prove that two triangles are congruent and which ones can't. Remember that side-side angle and angle cannot be used. Okay, so let's take a look at our first one, the side-side-side triangle. So we know if the sides of one triangle are congruent to the sides of another triangle, then the two triangles are congruent. And I know this is a little hard to read, so that's why you have a copy of it to write on, so that way it's a little more clear for you to see. All right, so our hypothesis. If we have three sides of a triangle and they are congruent to three sides of another triangle, so triangle ABC is congruent to triangle DEF, and we have to go in corresponding parts. All right, so triangle DEF. So let's take a look at a proof. Now this is something new for you. We're going to do what's called a two-column proof, okay? And we're given a couple of statements, and we have a diagram, and they're telling us that we need to prove something, and we have statements, a statements column, and a reasons column. So for every statement, we have to give a reason why we can say that that is true. So let's take a look at our givens first. Given, okay, so we have segment AR is congruent to segment ER. Well, I like to draw that on the markings on my drawing. It makes it easier to see. So segment AR is congruent to segment ER. So we're going to put that in the statement column. And the reason for that is given. It was given to us in the original problem. All right, the next one is segment AC is congruent to segment EC. So AC is congruent to EC, and again, that we can put that in the statement column. And again, that was given to us in the problem. All right. So now, what else do we know looking at this diagram? Well, we know that both of the triangles form or use the side RC. Now let's take a look at what we're trying to prove. We're trying to prove triangle RAC is congruent to triangle, and then it's going to be REC, okay? So we know that they both share the side RC, so segment RC is congruent to segment RC, and that's the reflexive property. Anything is congruent to itself. So that's the reflexive property. All right, and then the very last thing that's going to go in your statement is what you're trying to prove. So triangle RAC is congruent to triangle. Now you've got to make sure that you get the letters in the right order. Okay, so remember RA corresponds to RE, and AC corresponds to EC. So RA has to correspond to RE, AC has to correspond to EC. And we know that that is true because we have side, side, side. So by using the side, side, side postulate, we can show that those two triangles are congruent. So now let's turn the page and look at another one. Now we're going to take a look at side angle side. If two sides and their included angle of one triangle are congruent to two sides and their included angle in another triangle, then the two triangles are congruent. And remember, it's the included angle, the two sides in the included angle, which makes it side angle side, or you might see it written SAS. But we're going to write it out until we get comfortable with it. All right, so what that's saying is if two sides, so we've got two sides, excuse me, we've got two sides congruent to two sides and the angle that's in between, that's included. So there we have the angle that's included. So we have side angle, side, side angle, side. If those are congruent, then we can say that triangle ABC is congruent to triangle DEF. Okay? So now let's take a look at how that works in a proof. All right, so we're given that M is the midpoint of segment AB. So we're going to make that our first statement. Again, that's given to us. Now, from that, what do we know? If M is the midpoint of AB, well, what is a midpoint? What does a midpoint do? A midpoint is the halfway point but on a segment. So it cuts a segment in half. All right, so we can say that segment AM is congruent to segment MB, okay, because that's the definition of a midpoint. So our next statement is segment AM is congruent to segment MB, and that again was the definition of a midpoint. All right, now our second given is that M is the midpoint of CD. So if M is the midpoint of CD, that means that these two segments are going to be congruent. So first we need to write down our given statement. Forgot the word the. Again, that was given. So M is the midpoint of CD. And because we know that M is the midpoint of CD, we know that CM is congruent to MD. And again, that's the definition of a midpoint. All right, so those are all the givens. Now let's take a look and see what we're trying to prove. We're trying to prove that triangle AMC is congruent to some other triangle. Well, my hunch tells me that it's probably going to be DMB or BMD. I don't know. We'll have to take a look and see about that. But what else do we need in order to show that those two triangles are congruent? Well, we don't know anything about these sides, right? We don't know anything about these angles or any of that. But what do we know about angles 1 and 2? Yeah, we know that those are congruent because they're vertical angles. So we know that angle 1 is congruent to angle 2 because, again, they're vertical angles. All right, now we can go ahead and say that because of side angle side, our two triangles are congruent. Now we got to be careful about how we order the letters. So triangle AMC is congruent to triangle, now what corresponds to A? The B. What corresponds to M? M. And D corresponds to C. And we know that that is true. That looks like a P. We know that that is true because of side angle side. All right, let's try one more. All right, let's take a look at angle side angle. All right, if two angles and their included side in one triangle are congruent to two angles and their included side in another triangle, the two triangles are congruent. All right, so what that's saying is if two angles, so we've got angle, angle, oops, and that's congruent to these, and then the included side are congruent, then we know that the triangles are congruent. All right, so we've got to match our pieces. So if triangle, so we've got triangle ABC, and we're going to say that that's congruent to triangle D, but be careful here because look at the way I marked it, okay? Angle C is congruent to angle E, and angle B is congruent to angle F. So if we start with A, we start with D because they're corresponding. Then we go to B, well now we have to go to F here. So this is going to be DFE. We have to match the pieces. So A and D go together, so they're both first. And then B goes with F, so if B is second, then F has to be second. And then if C is last, then E has to be last. All right, so let's take a look at a proof. So given SE is congruent to SU, okay, we're going to write that statement in here. So SE is congruent to SU, and again, that was given, okay, and then angle E is congruent to angle U, and that's given. And we're trying to show that triangle ESM is congruent to some other triangle, and you can kind of see already that we're probably looking at this triangle here. All right, so how can we get there? Well, think about what we did on the last one. What do we know about angles 1 and 2? Yeah, we know that they're vertical, so they're congruent. So angle 1 is congruent to angle 2 because they're vertical angles. Okay, and now we have angle, side, angle, angle, side, angle. So we know that triangle ESM is congruent to triangle. Now what corresponds to the E? The U. What corresponds to the S? The S. And what corresponds to the M? The O. All right, so triangle ESM is congruent to triangle USO, and that is because of angle, side, angle. All right, so we've done 3 together, and I want you to do the next one on your own. Make sure you use pencil because we'll go over it in class. But you're going to do the angle side triangle congruence theorem, okay? So you're going to use angle side. You're going to do the same thing that we just did for the first 3, and then you're going to go through and see if you can fill out the proof for that. You don't need to worry about going on to the hypotenuse leg. We'll do that together. All right? So come in with this done, and we'll talk about it in class.